In example 2, we randomly select 16 coffee shops. That gives us our N value, the size of our sample, and we measure the temperature of the coffee sold at each. The sample mean of temperature is 162 degrees in Fahrenheit. So I'm going to go ahead and put that X bar is equal to 162. And we have a sample standard deviation of 10. So I'm also going to go ahead and put that S is equal to 10. Notice I put S, not sigma, because that was a sample standard deviation. We want to construct a 95% confidence level, so I know that my C is equal to 0.95 for the population mean temperature of coffee sold. So we are doing this still for the population mean. We're also given that the temperatures are approximately normally distributed, which is good because this sample size was not bigger than 30. So unless they had put that last sentence in there, we would not have been able to construct this confidence interval. So let's get started and find our critical value. Before we can find our critical value, we need to know that our degrees of freedom is n minus 1. So I'm going to take the sample size of 16 and subtract 1 to see that the degrees of freedom is 15. I'm going to head over to the t-distribution table. 15 degrees of freedom, 95% confidence interval. They meet at 2.131. So our critical value, T sub C, is 2.131. And again, I got that from looking at this table. Level of confidence was given in the problem is 95. The sample size was 16, so one less than that, the degrees of freedom is 15, and I find where they meet at 2.131. I think it's a lot easier to find critical values from the table because if you're going to find the critical value from the calculator, you need to first do some extra work to find this left area. It would still be 0.025 here because we're still working with a 95% confidence interval, but you do need to do some extra work to find that left area. When in the table, you can just go look it up. So now we have pretty much everything we need to go in and calculate our error using the formula T sub C multiplied by S divided by the square root of N. The critical value we found in the table, T sub C, was 2.131. S was given to us as 10, the sample standard deviation, and N was given to us as 16, that sample size. This comes out to be approximately 5.3. So now that I know the error, I'm able to find the left endpoint of this confidence interval by taking the sample mean of 162 and subtracting the error that we have of 5.3, which gives us 156.7. And we're also able to find the right endpoint of this confidence interval by taking the sample mean of X bar and this time adding the error to it. So I'm taking 162 and I'm adding 5.3 this time to give me a right endpoint of 167.3. So now I know that the confidence interval is 156.7 to 167.3. That is our confidence interval. You could have also written this, and this same goes for the previous lesson. You could also write your confidence intervals as saying, well, 156.7 is going, the actual population mean will be bigger than that, and the actual population mean will be smaller than 167.3. And all of these are in degrees because we are talking about temperature. And then I will give an interpretation of this confidence interval as well. So interpreting this, I would say that with 95% confidence, one can say, sorry, that thing's in the way. Okay, here we go. So with 95% confidence, one can say that the population mean temperature of coffee sold is between 156 degrees Fahrenheit and 167.3 degrees Fahrenheit. And I got those numbers from the left and the right endpoint of our confidence interval. So you will now try to construct and interpret a confidence interval on the next slide.